If you're wondering what is the difference between internal resistance, EMF, and electric current by solved problems, you've come to the right place. Let's get started. We are solving some practice problems related to internal resistance, EMF, electromotive force, and electric current. Here are a few solved examples. EMF, electromotive force, and electric current. Here are a few solved examples. Problem 1. A battery with an EMF of 12 volts has an internal resistance of 2 ohms. Calculate the current flowing through the circuit when connected to an external load of 4 ohms. Solution. To solve this problem, we can use Ohm's law and the concept of internal resistance. The total resistance in the circuit is the sum of the external load resistance, 4 ohms, and the internal resistance, 2 ohms. Total resistance, R, equals external resistance plus internal resistance equals 4 ohms plus 2 ohms equals 6 ohms. Using Ohm's law, we can calculate the current, I equals EMF/I equals 12 volts/6 ohms I equals 2 amperes. Therefore, the current flowing through the circuit is 2 amperes. Problem 2. A cell has an EMF of 1.5 volts and an internal resistance of 0.5 ohms. When connected to an external load of 2 ohms, calculate the potential difference across the external load. Solution. Similar to the previous problem, we'll use Ohm's law and consider the internal resistance. The total resistance in the circuit is the sum of the external load resistance, 2 ohms, and the internal resistance, 0.5 ohms. Total resistance, R, equals external resistance plus internal resistance equals 2 ohms plus 0.5 ohms equals 2.5 ohms. To find the current flowing through the circuit, we can use Ohm's law. I equals EMF/I equals 1.5 volts/2.5 ohms I equals 0.6 amperes. The potential difference across the external load can be found using Ohm's law. V equals I asterisk R. V equals 0.6 amperes asterisk 2 ohms. V equals 1.2 volts. Therefore, the potential difference across the external load is 1.2 volts. These examples demonstrate the application of Ohm's law and the consideration of internal resistance when calculating current and potential difference in a circuit. Remember to use the appropriate units, volts, ohms, amperes, when solving such problems. If you found this video interesting, go ahead and give it a thumbs up and let us know if we missed anything in the comments section. Be sure to subscribe if you want to see more videos like this in the future.